Stars basically fit into two categories, and it's strictly based on their mass. And so if we look at the life cycle of a star, and we start with a life cycle of what's called a low mass star, this would be a star like our sun. So our sun is a low mass star. It's not very big. It's not very massive as far as stars go. It's kind of average. So this background to this slide actually shows you all of the stages of a low mass star's life cycle. And we're going to start right here. Every star starts from this. This is a cloud of gas and dust. This is referred to as a nebula. And what happens is that all of these different particles in this cloud are gravitationally attracted toward each other. And so this cloud starts to collapse in on itself and condense in on itself. And this eventually forms a bright glowing area when all this material starts to get close to each other, close enough that the particles are knocking into each other and starting to give off some heat and starting to give off some energy. It forms what we call a protostar. Now, a protostar is not doing fusion. It's not hot enough. The pressure's not great enough. So it's a transitional point between the nebula here and the next step, which is here. This next step is what we refer to as a main sequence star. A main sequence star is actually doing hydrogen fusion. So this is hydrogen converting into helium. And this is happening right here. So this is step number 2. This is step number 1A, and this one is 1B. These are the different stages early in a star's life cycle. Okay, a main sequence star. This is where our sun is right now. It is in the main sequence stage. Then what's going to happen when hydrogen runs out? It's going to do helium fusion. Now, helium fusion is actually higher energy. So because it is higher energy, it causes the star then to expand and to become much larger because that fusion is pushing it outward more. And it makes that star swell into what we call a red giant. This star will be big enough when our sun becomes a red giant that the Earth will actually be inside of it. Now, eventually, as we talked about before, it's going to go through hydrogen, helium, carbon, oxygen, et cetera, until it reaches iron. And at this point, fusion stops. And then it puffs this outer ring of gases away, kind of like a bubble bursting. And this is what's called a planetary nebula. They're very beautiful. You should look at some pictures online sometime. What's produced here is we get this planetary nebula, and then we also get a white dwarf. And the white dwarf is this central part. You can see this bright white region right here. It's also right here. Now, white dwarfs are condensed because we've had this collapse of the star in on itself, and gravity is preventing it from continuing to collapse, so it's very, very dense. It'd be like taking an elephant and crushing it down to the size of a marble. Now, you and I couldn't pick up that marble because it was so dense. There's so much material in it. Now, white dwarfs are not doing fusion, but we are able to see them because they give off heat, and they do it for several million years after becoming a white dwarf. Now, the last stage is a black dwarf, which is this cold, dead mass of carbon, and you can just barely make it out right here in the slide. Now, this is not doing fusion. It's not giving off light. We can't see them, but some astronomers think that it's compressed carbon, super compressed carbon. And if you know anything that's super compressed carbon, that's like super compressing coal. And so astronomers think that this here might very well be a large diamond.